All right, so now everyone's here. So class.
Cheers.
Thank you. Now, I'm going to start off class by letting you guys know. I gave you guys the deck of cards. Now, on the deck of cards, I'm sorry, I could not print in color. So you're going to have to actually identify the colors. So the top row is clubs. Top row is clubs. What color is black?
Black.
Black, very good. Okay, so you're going to put this in there to make sure we actually know which one's which, right? Okay, the second row is spades. Spades are black. Next one is diamonds. Diamonds are red, and then hearts are red. Okay, so there we go. So as we go through this, now you know, so you can actually go through and list, because a lot of these things that we're going to do, we're going to select out of a whole. How many cards in this deck?
52.
There's 52 cards in a deck. How many? So, should you write that down on there?
I'm a certified dealer.
Hey, I'll tell you right now, is there jokers allowed in this? Say no.
No.
Okay, so, am I going to teach you how to count cards? Yeah. Or will you have the ability to do this? If you pay attention, you might be able to catch on to some of this stuff. So using this and probability is what I'm teaching. So the probability of getting something, and that's how counting cards works. You want to increase your probability to be able to count cards, to be able to predict what the next card is going to be. That's how counting cards works, by doing probability. And just trying to keep a running total in your head. Okay? So, by doing that, that means you can't just have, both earbuds in or playing on your phone. Especially on something that you might want to actually pay attention to. So, fundamentals of probability. What page are we on in our notebook today?
35.
So this one?
35.
35?
Yeah.
Okay.
Can I have a pencil?
Hell no, because you never give it back.
That's not true.
Did you forget your being recorded?
No, I did not forget. YouTube land. Hell no. Javi does not deserve another pencil because he's stolen like 9 already.
I want proof.
I would show you proof, but they're all missing.
Sounds like a personal problem to me then.
Hey, kind of like you missing a pencil right now.
I say fuck it, taking a word.
Okay. Probability. Okay, 100% or a probability of 1. This is important, especially if you're trying to play on your phone right now. Again, just remember that, okay? So what is the probability of Javi passing?
That's fucked up.
That's wild.
Okay,
Impossible is crazy.
okay.
Impossible is crazy.
So, right here, 100% or 1 is an absolute possibility. Okay, it is actually going to happen. Likely is in between here, somewhere in between the range of 50 and 100, like 75. Okay, 50-50 chance. Unlikely and impossible. Have you seen your current grade?
It's at a 41.
Hold on.
Someone that is a 0.8.
Said nigga, that's unlikely. Like, that's crazy.
41% is actually right here in the unlikely category.
I mean, if you decide to be generous, you can put me up with 50.
And what's the chance of that?
Impossible.
It is unlikely.
I ain't gonna say
Hey,
impossible.
but not impossible.
Yippee! Okay.
What you need? What you need?
Right.
If I leave
Anyway,
you on your
the
grade,
closer
got
the
me.
probability of a given event is to 1, the more likely that the event will occur. So, the higher your chance is up on this,
The more
it's more likely it's going to happen. That's the counting card principle. The closer the probability is given event to 0, the less likely that event will occur. Okay? So,
What if I buy you another goat?
I'm saying fuck it. I just need $200 in the fridge.
Name him Billy.
Just leave $200 in the fridge. You'll be alright.
okay. Vocabulary. Experiment is any occurrence for which the outcome is uncertain.
Wait, what was that?
I just read this.
I thought
Yeah,
it was a
uh-huh.
question.
So what's going on, Diddy? I don't know.
Stop
Okay.
it. That's not my name, bro.
Sample space is the set of all possible outcomes of an independent denoted by S. Now, I gave you people a deck of cards, right? That is my sample space. That is all the possibilities. Those are all the cards that you can get if I were to deal you one card. So your sample is all of those, right?
Yeah.
Good. Event denoted by E is a subset of a sample space. So if I have a subset of that, let's say all hearts, that would be a subset of the whole set. Okay, if I say only hearts, so that would be a subset from there. Okay? Sum of the theoretical probabilities of all possible outcomes is 1. Okay? Let's go back to this grade sheet right here. Let's say, for instance, we have someone is down here at 41%. Okay.
If you want
The likelihood, okay, no. Everything, all possibilities, has to add up to 1. Okay? So, possibility down here, okay, of passing would be down here. So that means at 41%, that's the possibility of passing. So up here, okay, there's 41% possibility of passing. What's all this over here going to be then? That is a 59% of not. So all probabilities add up to 1. So looking at that, okay, 41% chance of passing, 59% chance of not passing. So all probabilities go to 1, right?
Never tell me the odds.
Never tell me the odds.
If you just did homework, you would be up here. You would be closer to 1.
Well, my computer would actually.
Oh, now it's computer. All right. Anyway, so now that you understand the probability, now let's try and increase our chances here. Computing theoretical probability of event E has n equally likely outcomes, and the sample space S, n of S, equally likely outcomes. The theoretical probability of event E denoted by P of E is this.
What?
So you'll see it written like this, but it will make sense here in a second. So we're looking for the probability of this event here happening. Number of outcomes in event E divided by total number of possibilities.
But
What? Okay, now let's look at that deck of cards you have. Okay, so the total number possible would be 52. Okay, so what would be the number of outcomes, right? So if there's 52 total on the bottom, now what is the chances of me getting a heart? How many hearts are on there?
Oh no.
How many hearts? Say it.
13.
There's 13.
I forgot he explained to Jax.
There we go. So there's 13 hearts, and there's 52 total. So our probability, if I reduce my fraction, would be 1 out of 4, and turn my fraction into a decimal by dividing it. 1 divided by 4 is going to give me 0.25, right? 0.25, or as a percent, it is 25% that I'm going to pull a heart. Now, does that make sense? Is that a whole lot easier than the way that this is all written here? Yeah, I hope so. So yes, it looks kind of confusing, but it's really not that bad. You just need to understand what each thing is referring to. A die is rolled once. Do you know what a die is? It's a singular dice. Okay? Die is the singular for dice. Okay? On a dice, you have your sample space of 1, 2, 3, 4, 5, 6. So that's all the possibilities that I could roll, right? Okay. Now for part A. So my first fraction is, what is my total sample space here? 6. And to get a 3, what is my chances of getting a 3? There's 1 3, right? There's 1 3, so it would be 1 out of 6. Somewhat like that. What? You know you have a calculator, right? Okay, you know your phone is not just for looking up memes. Or staring at Instagram for, endless hours. Anyone actually do the math for me yet? Yes, 1 divided by 6.
Didn't you just post it?
What is it?
6.
1 divided by 6?
Yeah.
You did the other way around. Okay, so 0.116 repeating like that.
Yeah.
Or what would my percentage be?
60%.
16.6%, right? So we're writing it as a fraction first. We turn it into a decimal, and then we convert that decimal into a percent by moving my decimal point over twice, right? Does that make sense? Pretty easy now, right? Yeah? Okay, now let's try the other one. Now for part B, what is my total number for my sample space for part B?
Oh, 3. And 6 over 3 over 5.
No, how many total first?
6.
There's 6, and it says even numbers. So my even numbers are 2, 4, 6. And how many chances do I have there? 3. So I divide that. 3 divided by 6 is going to give me 0.5, which turns into 50%. Remember, you got to move the decimal over twice. Make sense, right? Okay, we'll keep going with it. There we go. Okay, now you guys got your cards. You are dealt 1 card from a standard 52 card deck. Find the probability of being dealt a king. Now, before you go far into this, I want you doing this one right now on your notes. Yes. Yes. Here, Cody, I got the deck of cards over here. Alright, so did he? Do you fill those out in the notes yet? Okay, so first, total number. It's going to be out of what? 52. Very good. So 52. And then how many kings are in a deck? 4. Very good. So 4 divided by 52 is going to give me 0.077. 77? Okay. All right. Now let's convert that into a percent, which is going to give me 7.7%. Now B, how many total? 52. And how many hearts are there? There is 13, which is going to give me 0.25, which gives me 0.5%. Now, empirical probability applies to a situation in which we observe how frequent an event occurs, and so computing empirical probability, so the probability event E is observed number of times occurs and total number of occurrences. Now, so let's say for instance we are looking at news or something like that, okay? So total number of observed occurrences. So we're looking at something, right? So I am, let's say I'm watching Diddy here, right?
That's not my name, bro.
Okay. I'm watching him, and every day he comes in my classroom, right? Okay. Yeah, just about. Okay. So I'm trying to watch this guy, and so I only can watch him on days that he shows up. So I'm looking for him every single day. But over the last week, I only saw him 3 times.
You're subbing me?
Even though that there is 5 days. So I'm looking for him 5 different days, right? And how many times do I actually see him? 3 times. So that's what this is referring to, empirical. So this is not an absolute, this is just going for observation. So we would say, using my empirical probability, that if he showed up 3 out of those 5 times, there's a 60% chance that he's going to show up tomorrow. But that's just what I have observed. Even though that we all know that Diddy, he needs to stay in school, he's going to be here every single day for the rest of the semester.
Have I not?
But because I observed something different, it is not always going to match what I'm going to get.
Like, to be honest, when's the last time I missed this class? I don't even know.
Okay. What, like Tuesday?
No.
Yeah.
You have
Tuesday. Yes, you did. You were supposed to come in Tuesday.
Okay, but
What about the I-Day on last Friday? How much did you do for your I-Day assignment?
Damn,
Exactly.
dude,
So don't even.
Shit.
So of those 2 days, I already called them out. Anyway, that's the difference in between. So empirical just goes with what we're going to observe. Now for this one right here,
Damn.
it is kind of weird to look at. Okay? It is kind of weird to look at, especially if you're not looking at this because you're staring at your damn phone again.
Like, to be honest, I can't
Now,
even be divorced.
Let's look.
Yeah.
In 2020, there are approximately 264 million Americans aged 15 and older. The table shows the distribution by marital status, sex of the population. Number of the tables are expressed in millions. Okay,
So, 60
now if we
million,
look at this,
46
now we look at it like this. You have to look at all the way across. So there is 128 million males, 136 million females. Okay, 264 total.
That's the whole population.
Does that make sense? So 264 total.
So,
Now, when we do it going the other direction, it's not going to be the same. Because as we look at each one of these, they all have to add up to my total down here. So there is, of these right here all together, we have 11 males that are currently divorced.
11 million.
Okay, 11 males, so 11 million males currently divorced. Okay, there is 15 million females that are currently
You
divorced.
see, females are.
And so all the total right here is 26 million together. Okay, so now, because these are like a Venn diagram, we have to actually use this, and I'll show you as we're asking for certain things. If one person is randomly selected from the population. Now, what is my sample size for this population?
264 million.
264 million, right?
Yeah.
So you take 100.
264 million is from there. Find the probability that the person is female. Okay, so what do I have to look for here?
Look at the total.
The total female, right? Okay, good. So I go all the way over here, so total females, 136. Yep, and I get,
I don't know.
this is for you to calculate, not to just say, I don't know. What is it? 0.
They got it.
Okay, so 0.51, which turns into about 51%.
Yeah.
Not too bad, right? Okay. So what does that mean? So that means the population in America is slightly more female than male.
Yeah, divorce like crazy and shit. To be honest, like,
do I have another one here?
like,
Yeah.
this is zero
All right,
percent.
so now let's try another one here. Now let's try this one here. So what is the chances? What is the chances that it's going, when I do the pick, a random number, and I want a divorced female?
So you take your total and then you grab 26 million and then divide it.
So on the bottom, I'm going to put how many?
Well, 264.
264.
And then you go put 26 on top.
And so now,
Oh, you're right. You're right.
okay, divorced female. So I'm not going to just female over here, right?
Yes.
I want a certain number.
15.
So that's why I have to go through and look specifically for those items. So that would be 15 out of there. Point zero what? So 5%. So 5% of the population here is divorced females.
To be honest, you don't have bad.
All right, does that make sense?
See,
Hopefully.
see.
All right, so I want you guys trying the homework. Start working on it right about when? Meow. Okay, I'm hoping you guys can get most of this done here today. We're going to work on it again tomorrow. Make sure you guys all like, share, and subscribe.